Welcome to my YouTube channel, where we delve into the exciting world of modern software development and deployment. In today's episode, we are diving deep into the game changer that has revolutionized the way applications are built, shipped, and run. I'm presenting to you the Docker, the powerhouse of containerization, empowering developers and businesses to unlock unparalleled speed, efficiency, and scalability. Discover how Docker enables seamless collaboration, eliminates environment inconsistencies, and supercharges your development workflow, bringing your ideas to life with lightning speed. From cutting-edge microservice architecture to streamlined CI/CD pipelines, Docker has become the go-to tool for modernizing applications in today's rapidly evolving digital landscape. If you are ready to embark on a journey of innovation, efficiency, and accelerated software delivery, hit that subscribe button and join me as we explore the limitless possibilities with Docker. Don't miss out the Docker revolution. Subscribe now and let's unlock the full potential of containerization together. Docker is an open platform for developing, shipping, and running applications. Docker enables you to separate your applications from infrastructure so you can deliver software more quickly. With Docker, you can manage your infrastructure in the same ways you manage your applications. By taking advantage of Docker's methodologies for shipping, testing, and deploying code quickly, you can significantly reduce the delay between writing code and running it in production. Docker provides the ability to package and run an application in a loosely isolated environment called container. Isolation and security allows you to run many containers simultaneously on a given host. Containers are lightweight and contain everything needed to run the application. So let's take a look at the architecture of the Docker. Docker architecture. Docker architecture consists of three major components: client, Docker host, and registry. Docker in the client, which is a CLI utility, where I can able to run tons of commands to connect with the Docker host. For an instance, Docker run is a command used in Docker to create and start a new container from a Docker image. It is one of the most commonly used Docker commands and plays a fundamental role in running applications in the Docker containers. Docker build is a command used in the Docker to build Docker image from the set of instructions specified in the Docker file. The Docker file contains a series of instructions that define the steps to build the image, including adding dependencies, copying files, and setting up the environment, and many more. Docker pull is also a command used in Docker to download the Docker image from a container registry such as Docker Hub or a private registry. It allows you to fetch and store a copy of a specified image on your local system, which then can be used to create and run containers based on that image. These clients connect to Docker daemon. Docker daemon, also known as Docker, is a background service that runs on a host machine and manages Docker containers, images, networks, and storage volumes. It is responsible for handling and executing Docker commands and interacting with the Docker API. Docker daemon performs the following key functions: accepting Docker API request, managing Docker objects, container runtime engine, image management, and many more. When it comes to the Docker host consists of images and containers too. Docker host refers to the machine running the Docker daemon. Docker images are the templates used to create containers, and Docker containers are the running instances of images that encapsulate and execute applications. Docker provides a flexible, efficient way to manage and deploy applications by leveraging these concepts of host images and containers. Finally, there is another section, there is a component called registry. Docker registry is a central repository that stores and manages Docker images. It serves as a distribution hub where users can upload, store, and download Docker images. Docker registries facilitate the sharing and distribution of container images among teams, organizations, and broader Docker community. The primary functions of the Docker registries include image storage, image distribution, access control, image versioning and tagging, public and private registries. Docker Hub is basically the default and the most widely used public Docker registry, hosting a vast collection of pre-built images contributed by the Docker community. However, organizations can also set up their private registries using tools like Docker Registry, Harbor, or Elastic Container Registry from AWS. We call that as ECR. In summary, the Docker Registry is a central repository that stores and manages Docker images, enabling users to distribute, share, and retrieve container information, that is images, for building and deploying applications. Finally, we have extensions and plugins. Docker Registry supports plugins and extensions to enhance its functionality and integrate with various systems and services. These plugins and extensions provide additional features, customizations, enhancements, and capabilities to the Docker registry. So in a nutshell, this is the core functionalities of the Docker architecture with different components played together. Let's take a deeper, more look at the details of Docker image. So Docker image is a lightweight standalone executable package for software that includes everything needed for an application. For example, it has a cut down operating system and it is having a runtime environment for your application to run. So all the dependencies, all the runtime related environment needs to be done. Then it's basically the application files. The files required for running smoothly for applications. Any third-party libraries needs to be included as a part of the package. Then the environment variables. These are all the 5 different items are required, needs to be bundled together because it has all the files needed to run the application. Whereas the container is a runtime instance of a Docker image. A container will always run the same regardless of infrastructure. Containers isolate software from its environment and ensure that it works uniformly despite differences, for instance, between development and staging. It is like a virtual machine. It has its own runtime environment, application files, and third-party libraries and environment variables. So when I build an image in my development environment, I need a container to run that image in an executable form. So basically that is the difference, fundamental difference between an image and the container. You need a container. Container is nothing but a process in which I can apply the image into this and execute in a runnable form. There are different steps involved in the Docker workflow. So first one is I code the application with the multiple files, which I stated that there are different files associated with my application. Then finally, once my application files are done, then I create a Docker file. So once it is done, I create the image. The image is basically defined at the Docker files. You run the container and basically it does the microservices. Once the Docker image is done, once you validate that, you could push the container to the Docker Hub. So then this is basically how the workflow works like. For example, as a developer, you get started on your coding by leveraging Docker image to efficiently develop your own unique applications on the Windows or a Mac operating system. Create your multi-container application using Docker Compose. Integrate with your favorite tools throughout the development pipeline. Docker works with all development tools like Visual Studio Code, Circle CI, GitHub. Then package applications as a portable container images to run in any environment consistently, from on-premise Kubernetes to Azure, Google CE, and more. Then basically, then you can share the The image. Leverage the Docker trusted content and include the Docker official images and the images from the Docker verified publishers from the Docker Hub repository. Innovate by collaborating with team members and other developers and by easily publishing images to the Docker Hub. Personalize developer access to the images with roles based on access control and get insights into the activity history with Docker Hub audit logs. Then basically you run it. You deliver the multiple application hassle-free and run them the same way on all your environment, including design, testing, and production. Then what do you do? Just basically go to the production environment. Actually, you pull that specific Docker image. So the same container file and the image file into the container, once you publish it in the hub, you could go to the production or non-development environment and you could just publish that image and you just start working on it. So you deploy the application in separate containers independently and in different languages. Reduce the risk of conflict between languages, libraries, and frameworks. It speeds up your development with the simplicity of Docker Compose. So launch your application, test the code, then boom, then basically that's it. That's the process of the entire development life cycle. So now let's get started with the installation process of the Docker. So Docker installation is very simple. First, the installation step is to download the Docker from this location docs.docker.com//docker- for Mac, because I have a Mac machine, /install. You download the DMG file and then all you need to do is double click it and then you install it. Then let's go and check the Docker version that we installed. The Docker version. Before I run this command, I want to make sure my Docker is started. So you see this using the Docker icon. If I click it, it will initiate the Docker process in the background. So let's give a few seconds before it gets started. Cool. So the Docker is started and the version, server engine version, is 24.0.2. It means the Docker has been installed in my machine. So now let's go back to the step number 3 in the installation process. Now I need to download the Visual Studio Code. This is more like an IDE. I just write the code for my application. Also, I can create a Docker file. Then you could do the Docker image build right there. Also push it to the Docker Hub and registry. So let's take a look at this. Is same process. Is download the zip file from this location. Then I'm going to start the Visual Studio. Once I start the Visual Studio, I need to set up the code path. Why I need to do the code path? Because from my terminal, if I type the word code, it automatically opens up Visual Studio. And let's take a look at it. So this is my Visual Studio. So in that, I go to settings in the command palette, specify code. It will give you the shell command install code command in path. Click on it. Then the pop-up window will come and display the message, the shell command code successfully installed in the path. So what does that mean is I go to the terminal. Here I type code. It opens up. Okay, so that's basically the step to install the Docker and Visual Studio, followed by how to set up the code path. Let's see Docker in action. In this lab, I'm going to create a smart web application pretty quickly, build the Docker file, run an image into the container and test it, make sure it is running fine, and also walk you through how to upload it. That is kind of a pushing into the Docker Hub so that people can able to download on their own container and run it on their own. So it's a very quick step, but it's certainly needed as a part of a Docker workflow. So the first step is basically to start with an operating system. I'm going to install the node because the web application is dependent on the node.js, and the entire building and deployment process is only 4 steps. So 4-step process. Afterwards we're going to access the web application. So the web application is basically you run it, make sure they're working fine. Now the step number 1 is to create web application. So in the terminal, I am in my home directory. From this location, I am going to open Visual Studio using code dot. Dot basically takes that folder, my first web application, directly into my Visual Studio Code. So the code is open. Now in this, you see this plus icon. In this plus icon, you click this. I'm going to create a file name, server.js. In this, I have a code so I'm gonna paste it here. So code under server.js. Afterwards, I'm gonna save this. Then this is the only file. Then afterwards, I need to create another file called the Docker file. Either way, you just right click and create new file, or click this little icon. Here, the name of the file is Docker, D in uppercase, file. Open this file, paste it here. What it's going to do is, it's actually sourcing the Node 14th version. My working directory is /app, and the copy, the dependent package.json, where I'm actually creating all the configuration. Then it will gonna install the dependencies, the node, all the other dependent softwares, then copy it and expose the 3000, that's the port number. Then all I need to do is just to run this container file and create an image. So I'm going to save this. That's it. So when I'm done, now it's the time to build the Docker image. So I go here, you see this under the folder, the 2 files have been created, Docker file and server.js. Now using the CLI, I need to run docker build -t my first web application is the name of the file, name of my application. I need to put dot. So it's gonna build that application, the image, under this folder, current directory. It has been completed. Now the next step is step number 4 is to run the Docker container. How to do it? It's docker run -p. One important step I like to give an update. See, if I put ls-ltr, so you don't see this. The Docker, the image which has been created, it's not there underneath. It's stored in the Docker, the registry. So let's see how I'm able to access it. Is docker images. So you see this, my first web application, and you see the repository and the tag, image ID, and created. So what happened, as soon as I build the application, build that image file, it stores that image file into the repository. So that is hidden. I'm not able to see it in the folder which I created my application. So afterwards, all I need to do is run it. There are a couple of ways to run it. I'm going to run it from the command line interface. So how I'm going to do it? Docker run -p, my port is 3000, and name of my application. The name of my application is my first web application. It has been started. So let's say I go to this URL and then go to my browser and see if that works. Localhost 3000. Cool. So the application is running. Hello Docker, that is the message that I encapsulated in the server.js. So now I'm able to run the application. There are a few little commands that I want you to aware how to run it in the command line interface. So I'm running this application, right? It is currently in progress. If I want to stop, So now the application is running. I want to see the number of containers are presently running. So what I'm going to do, docker ps. You look at it, the container ID is currently in progress, is running, and it is using this application, my first web application. So now I want to stop. So how am I going to stop it? Again, there is a command where I'm going to do docker stop and the container ID. So I copy this and paste it. Enters. It has been stopped. Now go back to the prior tab. Yeah, $prompt came in. It means that application, the server is stopped now after the command issued. So that's basically one of the CLI command that I want you to know how to start and stop the containers. Now I open the Docker desktop, and this is the application which I created the tag rawnvr / my first web application. So what I'm going to do is I click here, and you see this option. I'm going to push it to the hub. So it's done. Hub.docker. See what I published or the push the local container. Now it is in hub.docker.com. So that's basically how I can create a application and build this image, then push it to run it in a container, then push that image into the hub. So probably in another environment like a production environment, I can download it and I can work on it. So this is the overall process. So what we did, we built this web application locally, right? And we built it and we ran it in a container locally. We tested, everything looked good. So what we did, I pushed it using Docker Hub into my folder under Docker Hub, rawnvr sample web application. Now it is publicly visible, so I can go to my production environment, connecting to the Docker Hub, or since it is public, I don't need to connect. I can just specify the folder and also the application name along with the tag. So you could just search and download it. When I do it, I can pull it to my production environment. So anybody could pull it on their local environment and they could run it. If you like it, please like, comment it, and share it with your friends. Please don't forget to subscribe to my channel.